We are recording and audio since we're going to train anyone here. It does sound spin. It is first hour. All right. On Friday, when we did one quick, we looked at two set equations that have multiplication into a coefficient and a variable. Today we are looking at equations where we have a lot more fractions. And by fractions, I mean both fractions, like these are fraction coefficients, but then also we've got some division happening here, and then we've got some division happening here. So we organize the note sheet. These two equations get solved basically the same way. These two equations get solved basically the same way. These two equations get basically the same way. Okay? So starting with these first ones, these start the exact same way equations we want to do, which is we're going to get rid of what we're adding or subtracting first. If you are a person who likes to draw a line down to equals, now would be a great time to do that. So add 2 to both sides, and 2 to both sides. We have x over, so not x, 4/3 x equals 14 plus 2, which is 60. All right, from there, we need to get rid of 4/3. There are a lot of different ways we can do this, because what 4/3 means is 4 times x divided by 3. So we can multiply 3 and then divide by 4. The other thing that you can do anytime you're trying to get rid of a fraction coefficient is you can multiply by the reciprocal, which is that fraction flipped over. So we have to multiply on both sides by 3/4. All right, I'm not going to do this on every single problem, but I want you guys to be able to see why this is allowed. So right here, if it's 3/4 times 4/3, I'm just going to do it off to the side in a different color. 3/4 times 4/3. 3 times 4 is 12. And first is 12. And what's 12 divided by 12? 1. So these, we use the word cancel out, just like bringing cancel out. They cancel the left because they reduce to 1. So that's why we are multiplying by our reciprocal. So now on the left, we just have our x. Okay, on the right side of our equation, we would put that 16 over 1 and multiply like we did in our distributive fraction. We could, or we can use our calculators. Fractions are divisions. 16 times we divided by 4, and we get a nice even 12. Sometimes you will get a whole number. Sometimes we get a fraction. I think the next one will get a fraction. I'll show you guys that when we get there. You can also think 16 times 3 is 48, and 48 divided by 4 is 12. Any questions about the first one? Thunder is really great. Okay, next one, we've got 2/5 x plus 3 equals -4. We're going to start, draw our line. I'm going to get rid of that plus 3 by subtracting 3 both sides. So I've got 2/5 x equals -4 minus 3 is -7. Okay, to get rid of that 2/5, we are going to multiply both sides of our equation by 5/2. 5/2. 5 is 1/2, also 1. So on the left side of my equation, I just have x now. On the right side of my equation, I have -7 times 5, which is -35/2. That does not add up to a whole number. I could leave it as a fraction if I wanted, -35/2. But 35 halves is kind of like a goofy thing. So this is one where it would make sense to change it into a decimal, and it's nice even decimal. That's allowed. We're not doing decimals when it's like a 0.33333 or whatever, but this is a nice decimal. Okay. Thoughts, questions, anything right now? Right, so that is one type of equation that you might see with a fraction, and that is how you tackle that fraction coefficient by multiplying by the reciprocal. The next type of equation that you might see fraction, I think big fractions because they're like physically wider, larger. So these ones, what this means is that everything on top here, x plus 3, is all getting divided by 6. So for this one, we are going to start getting rid of that 6. So the opposite of dividing by 6 is multiplying. We're going to multiply both sides of our equation by 6. On the left side, this 6/6 is 1, so it reduces away. I've got x plus 3 equals, and then 2 times 6 is 12. Then, to get rid of that plus 3, we are going to subtract 3 for both sides. X equals 12 minus 3, which is 9. Okay. The next one works the exact same way. There's some decimals to start, there's going to be some decimals to end. That's nothing to be worried about. We just keep on math like normal. So we are dividing everything by 5. So we need to multiply everything by 5 to start with. Multiply by 5 on the left and right. On the left, we have x minus 2. On the right, we've got 4.03 times 5, which is 20.15, 20 and 15 hundredths. And the last thing you do to get my variable by itself is add 2 to both sides. 2, 2. I've got x equals, I tried to line it up there. I'm adding in the 1 place, so it's between 2.15. Okay. Equals increment. Last 2 setups, we got last 1 setup, but we got 2 problems for each setup. This, we call these little fractions. It's just a little tiny narrow fraction. So if we've got a problem like this, we need to get rid of that minus 12 because the only thing that's being divided is the x. So we're going to get rid of that minus 12 first. We'll add 12 to both sides. We got x over 3 equals negative 14 plus 12. I owe you $14. I pay you 12 back. So I've almost paid you back. I still owe you 2 though. That's negative 2. Okay. Then now we have a one-step equation, x divided by 3. Opposite dividing is multiplying, so I'm going to multiply sides by 3. Both sides by 3. Got x equals, on the right side of our equation, negative 2 times 3 is negative 6. All right. Then our last one we've got here is x over 4 plus 8.2 equals negative 8. So exact same setup, but again, we've got some decimals. We just treat them like normal. Subtract 8.2 from both sides. And I made this problem. I made it so that it does this. Negative 1.8 minus 8.2 is exactly 10. Well, negative 10. Negative 1.8 minus 8.2, exactly negative 10. So I made gross numbers turn into nice numbers. They weren't that gross. One decimal is not that gross. Okay, and then the opposite of dividing by 4 is multiplying by 4. So we'll multiply both sides by 4. And we'll get x equals negative 40. Negative 10 times 4 is negative 40. Hey, there is no back to today's note sheet, so you are able to just glue it into your notebook flat. You don't have to do any complicated folding. I don't think there's any. I will say though, composition notebooks used to be 100 pages, and we could do just fronts. They're now only 80 pages for inflation. You need to glue it to the back of where your 1.1 notes were. So wherever your 1.1 notes are, glue it to the back of that page. So you should be past your pocket. You should have 1.1 notes on our front, and then glue your 1.2 notes on the back. So you'll go front, back for your notes. All right, I'm gonna go ahead and stop this recording. I don't know why it's working.